If you go back to introductory calculus and you recall studying the idea about critical points for a function of a single variable, you remember that we could find that by taking the first derivative and setting it equal to 0 and solving for the values that make x or whatever input variable equal to 0. And remember, we could also check for the places where the derivative did not exist, and those points were called critical points of the function. For multivariable functions, you have very similar behavior. What you have is if I have some function defined on some open region R, and actually that's technically the definition even in introductory calculus, but sometimes we forget that that's a requirement. We say that this point x0, y0 that's in that small open region, so basically you have a point and some small area around it. If the function's defined there, then this point is called a critical point of the function if one of three conditions are met. The first one is that both partial derivatives are equal to 0. So take the partial with respect to x, partial with respect to y, set them equal to 0. And they're equal to 0 at that point. The second one is if it doesn't exist at that point, or if either partial doesn't exist, then it's also a critical point. So for practical purposes, the way you would want to go about this is if you have a function, you take its partial with respect to x and you take its partial with respect to y. Then you take a look and say, all right, where is this function not defined? You might have a case where after the derivative, you have 1 over something. So you know that if it's equal to 0 on the bottom, it's not defined there. So that's a very common situation. So once you've found the places where they don't exist, then you start solving to find places where they're both equal to 0. So this one's a little more challenging usually than these two. But by doing that, you can build a set of critical points, and then we're going to develop some theory as we go along to determine whether or not those points are maxima or minima. And just as a simple case, if a point is a relative extremum, if it is a maximum or minimum, it's also a critical point of f. The reason I want to point this out is that you will have, this is an if condition. This basically says these are what was called sufficient conditions. If I can find cases where these are true, then I know it's a critical point. But this also shows that there might be cases that none of these are satisfied, but still happen to be a critical point of f, and it just helps expand our understanding of what we're talking about.